To all of you already subscribed, welcome back to the Foundry of Ideas, where precision meets practicality. And if you're new here, this is the place where tools, jigs, and ideas are built from the ground up with real detail, real intention, and zero shortcuts. Today, I'm excited to show you the build of a DIY sled that will make one's workflow way more efficient, a 2-in-1 sled that works as both a crosscut sled and a miter sled. It's a build that involves some new and clever ideas, and the precision it offers is no joke. That's a great project with lots of potential for both seasoned woodworkers and beginners. As always, I'll walk you through every step with clarity, pointing out which materials and tools give you the best results, especially if you're working with what you already have. No guesswork, just clean, repeatable outcomes you can count on. For my sled I chose to use MDF because I had a suitable board and also because MDF is stable under different weather conditions. This board measures 6 10mm, 24 and 1/64 inches, by 4 10mm, 16 and 9/64 inches, and its thickness is 12.5 mm, 31/64 inches. In the foreground you will see that I have drilled 13 holes which I have fitted with M10 size threaded inserts. The arrangement and locations of these inserts is what I thought would best serve different sizes and angles of miter cuts. At the far end, left side, I first made a very shallow recess of 1.13 mm, 3/64 inches, depth, that accepts the lower ruler of a digital angle measuring instrument. Within this slot I drilled 5 holes, arranged on a straight line that is parallel to the short edge of the board. In these holes I fitted M5 threaded inserts. These will accept 5 hex bolts which will hold secure the lower ruler of the digital angle measuring instrument. At a distance of 102 mm, 4 and 1/64 inches, from the right hand side I have made a suitable slot to accept a number 19 T-track. I shall explain the purpose of the M10 inserts and the number 19 T-track shortly. Here I have turned the board so that a better view of the recess for the angle measuring tool can be seen. Please note that a deeper recess has been introduced at the right side of the slot. This had to be done, with a Forstner bit, to accommodate the shape of the digital case pivot. A cut with the table saw blade has also been made for reference during the construction process. You will note that on the left-hand side I have added an extension. This will carry a stop block for the miter fence. The mechanism that will be fitted here serves to provide an accurate stop for the miter fence, so that the latter stops when it is at right angles with the right side of the board, along which runs the blade of the table saw. This extension partially supports the number 19 T-track as well. I shall explain how this system is set up in a minute. Here one can see the left-hand side of the sled. This view shows us where the miter fence will be located, i.e., the right side as we look at this view. If we now look at the left end we see the 2 pre-drilled holes that will hold the plywood support fence of the actual crosscut sled part. It is on this plywood sub-fence that we shall mount the aluminum main fence. The nearest hole will accept an M5 bolt which will act as the pivot of the sub-fence. On the other side, that is the far left side, there is an elongated opening. This arrangement allows for a certain rotational freedom, which in turn will enable the sub-fence and the aluminum fence that is secured on it to rotate around the pivot until the whole arrangement is at right angles to the cut made on the sled by the table saw blade. You may have been wondering as to what the purpose of the T-track is. Well, this is a substitute of having to cut an arc on the actual sled, and the way that it is allowed to do the job of an arc is quite clever. All will be revealed in due course. Here are 2 more views of the plywood sub-fence. Here we show views of the sub-fence with the main aluminum fence mounted in position. Here we have a better view of the wood block that protects one's fingers from the advancing blade of the table saw. Please note the 2 stoppers fitted on this fence. Here, in the sequence that follows, I have shown, 1. The miter fence with the digital angle protractor mounted on its base, left side, as shown. 2. There are 2 miter track stoppers provided for this fence. The length of this fence is 500 mm, 19 and 11/16 inches. UHMW, ultra high molecular weight, self-adhesive tape, has been applied to the underside of the ruler, which is fixed onto the miter fence with short hex bolts. This tape protects the surface of the sled from the friction produced during movement of the miter fence, whilst at the same time it facilitates a smoother glide too. The lower ruler of the digital angle protractor has been secured onto the sled with 5 hex bolts of short length, 16 mm, 5/8 inches. Here are several views of the glider that I made, which serves to enable the circular movement of the miter fence. This glider is made of an aluminum angle bar, 36 mm by 52 mm, 1 27/64 by 2 3/64 inches. Its length is 88 mm, 3 inches, and it is 3 mm, 1/8 inches, thick. It is fitted with 2 T-track bolts, one for inserting into the miter fence slot and one for inserting into the red T-track. Ultra-high molecular weight self-adhesive tape has been applied to the faces of the glider which are in contact with the miter fence and with the T-track, respectively. Thank you for patiently waiting. Here the glider can be seen fitted on both the miter fence and the T-track. The next clip shows the miter fence moved to the end of the sled. For reference, I would mention that the UHMW self-adhesive tape also provides a clearance between the digital protractor ruler that moves with the miter fence and the surface of the sled, so it makes for an easier movement too. The last clip shows the miter fence having been moved to an angle of 60 degrees. For the convenience of the miter fence operator, I have made a stopper that prevents the movement of the miter fence beyond 90 degrees to the right-hand side edge of the sled, which is the side where the blade of the table saw moves. This stopper arrests, so to speak, the miter fence when it is exactly at right angles to the plane of the table saw blade. A threaded insert has been fitted on a small block of wood. A T-bolt has been threaded through this insert, and on the side of the turning knob a washer and a nut are fitted. Once the miter fence has been ascertained to be at right angles to the sled's right-hand side, this nut is tightened so that the T-bolt is immobilized and secured in position. This way the miter fence can always be accurately returned to a position of 90 degrees to the sled's right-hand side, as viewed here. This is a very simple stopper to make that is highly efficient and accurate at the same time. I have positioned this stopper on an extended piece of MDF which is screwed and glued to the sled board. This is necessary to avoid any contact or interference with the miter fence glider when the fence is returned to 90 degrees to the right-hand side edge of the sled. Now let's look at how we set the stopper when the miter fence is ascertained to be at 90 degrees to the right-hand side edge of the sled. First of all, we turn the knob of the stopper so that it is well clear of the surface of the miter fence. We then employ a universal angle square for marking and guiding the miter fence in relation to the right-hand side edge of our sled. This must be an angle square known to be accurate. Once we are certain that one side of the angle square is totally in line with the right-hand side of the sled and that the miter fence is also in contact with the angle square, we use a clamp to keep the latter firmly in position. We then proceed to turn the knob of the stopper clockwise until it contacts the miter fence, ensuring that this movement of the T-bolt has not altered the position of the fence. Once we are satisfied that we have an acceptable contact between the T-bolt and the fence, we firmly tighten the nut near the wood block to completely immobilize our T-bolt. This is the successful end of this exercise. So far, we have dealt with the miter fence. Now the time has come to set up the sub-fence and the main fence of the crosscut side of our sled. The bolts are in position on the main board and the sub-fence has been placed appropriately. Washers are put in place, and this is followed by applying the knobs that will hold the sub-fence in its correct position. We do not tighten the holding down knobs at this stage. Once this has been accomplished, the main aluminum fence is inserted by using the T-bolts already in position. The main fence is tested with a 45/90 degree angle T ruler or multifunctional angle ruler, to prove that the fence is lying vertical to the board of the sled. As can be seen, the fence is actually vertical to the main board, so this test has been passed. Our second target is to set the main fence of the crosscut arrangement at 90 degrees to the cut of the table saw blade. For this purpose, we use an angle square that is tight-fitting to the cut of the blade. Once this is in position, we shall use our universal angle and tri-flat square to set the fence as shown. Here we make sure that there is a firm contact, 1 between the flat square and the angle square and 2 between the flat square and the main fence. When both of these conditions are satisfied, we shall tighten the holding down knobs of the sub-fence, and so we are successfully done with our second target. As we can see in the next clip, we have created a combination of a crosscut sled as well as a miter sled all on one board, and because of the position in which we have placed the T-track slot miter bar slider, all we have to do is turn the board around in accordance with the operation we want to complete and carry out our work. One sled does it all. This is the complete tool. To complete our project, we still have to do some additional work. Number 1, we must make a cut through the protective wood block of the sub-fence. Number 2, we must demonstrate that both of the fences do successfully and accurately produce the cuts we designed them to do. Number 3, I wish to incorporate a safety feature that will ensure that the cutting blade of the table saw never exits beyond the protective block of the sub-fence. Finally, I would also like to show you how the glider operates. So, let's get to it. The following clips show each of the objectives as set out above. Number 1 is self-explanatory. Next I show how we test the crosscut fence. For this purpose we employ a board the sides of which are parallel to each other. We proceed to cut this board in half. We then put the resulting 2 boards against the fence and bring them together. The faces of the boards, where the cut was made, meet with no divergence from each other. Next we repeat this test by turning one of the boards upside down, and then again, we bring the 2 board faces together. Once more we observe that the 2 faces of the cut meet each other perfectly, with zero divergence or gaps of any sort. These tests prove that the fence is at right angles to the table saw blade path. As can be seen here, it is very easy to rotate the sled on the table saw, so that we can now use the miter fence side. As a next step, we set the miter fence at 45 degrees to the right side of the sled, and we secure a board to the sled with clamps. Once the board is firmly secured to the sled, we proceed to make a cut. Once the cut has been completed, we set the cut piece against a set square and we observe that the cut edge of this board faithfully and calmly coincides with the 45 degrees edge of the set square. This test proves that our miter fence can produce cuts in accordance with the setting of the digital angle gauge. Here is a demonstration of how the glider operates when the miter fence moves. First, fully loosen the two knobs. In direct continuation, push the glider forward and to the left to move the fence away from the stopper at the left side of the table saw front. To return the miter fence to the stopper position, pull the glider toward the front of the table saw, whilst slightly pushing it to the right hand side. It is very easy to operate the glider. Please note that the maximum angle to which the miter fence can be set in relation to the front of the table saw is 60 degrees. This view shows both fences stowed in position on the sled. During this test I have shown the use of the glider, as well as the purpose of the M10 threaded inserts, that we installed on the sled board earlier. They are there to accommodate the clamps, at different positions, depending on the shape and size of the board we are about to miter cut. Clamps must always be used, without any exception, because the forces exerted by the cutting blade in conjunction with the movement of the sled whilst cutting may result in a kickback of the board that is being cut. Here is the safety strip that prevents the exposure of the cutting blade beyond the subfence protective woodblock. Bring the sled to a position on the table saw where the cutting blade is just about to be exposed at the back of the protective woodblock. Mark the strip of wood that is fitted in a sled slot for your reference and then fix it in position with a screw. On the end of the wood strip a small stopper has been glued in position with CA glue. As can be seen, this arrangement prevents the sled from moving beyond a position that would cause the table saw cutting blade to be exposed. This is a simple, but very effective safety arrangement. This diagram shows the dimensions of a DeWalt DWE 7485 GB table saw. It includes the locations of the two slots for the guides and it shows the path of the cutting blade. A cross-section of the slots and their dimensions are also shown. Here are the dimensions of the sled. The locations of the number 19 T-track and of the path of the cutting blade are included. Here is a little geometry for all the aficionados out there. Here are the parts that one needs to build the miter fence stopper. 1 threaded insert, 1 T-bolt, 1 knob, 1 washer and 2 nuts. I put a lot into each project video to make sure it's not just inspiring but actually usable. Every tip, every tool choice, and every technique I show is something I've tested to get the cleanest, most accurate results possible. So if you're into building smarter, cleaner, and with confidence, make sure to subscribe, tap that bell so you never miss a build, and give the video a like if you found it helpful. And I want to hear from you, seriously. Drop a comment below. Whether it's a tweak you'd suggest, a feature you'd add, or even how you might adapt this for your own shop, your input doesn't just help the channel, it helps the whole community. Let's build better, together.